Okay, so this week we are going to talk about three-dimensional space. Okay, so we have worked in a two-dimensional XY plane for a majority of the year. Okay, now we are adding a third dimension, Z, which means we are in space. Okay, you and I are three-dimensional figures living in space. Okay, we're not living in outer space. We're living in three-dimensional space. Okay, two dimensions, we are in planes. Okay, so what we have is an X, Y, and Z axis. Now you can see my drawing here on the board. I drew each of the axes to where the solid line is where these are positive. The dotted lines are where these are negative. Okay, this is the only time I'm going to draw them like this, but I just want you to see what these look like. So the Z is up and down, where the top is positive, bottom is negative. X is shooting out at you, where towards you is positive, away from you is negative. And then Y is kind of traveling where the right is positive, the left is negative. Okay. Three space is made up of three planes. Okay. We have the XY plane, which is what we're used to being in, and that's like the floor would be like the XY plane. That's what we have that direction. Okay. And then we have our Z axis, which is new. So now we have an YZ plane, which would be like this wall that I'm standing in front of. And then the XZ plane, which would be like the wall with the window. Okay, so that corner of my room would be considered the origin, and we are all where X, Y, and Z are positive. Okay, if we go with what I just described. Okay, so when we have the XY plane, we had 4 quadrants. Now that we have 3 planes intersecting, how many different sections are we going to have? I'm hearing 6, I'm hearing 8. I'm hearing 6, I'm hearing 8. How many? 8. 8. Okay. So this is a very janky thing here. We're going to go with it. Okay. So those of us who really like visualizations, I'm trying here, okay? If you have your book and you open it to page, I'm not sure the exact page, but just the first page of 11.1, there is a figure that highlights each of the 8 octaves, okay? We're going to go through and we're going to name the 8 octaves. Okay, it's going to be very similar to how we name the quadrants, okay? Now let's stand up here and hold this for me. I need to hold that line. Yep. Okay, so here we go. This is how we're going to name our octants. Right here, where X, Y, and Z are all positive, that's 1. And we're going to rotate around. 1, 2, 3, 4. Lift up a little bit. Below octant 1 is octant 5, and we go in the same pattern. 5, 6, 7, 8. So 1 through 4, Z is positive. 5 through 8, Z is negative. Okay, one more time, let's name the octants. Right here, 1, 2, 3, 4. Below 1 is 5, 6, 7, 8. Okay, thank you very much. Thanks. Okay, so we are going to plot these points. Okay, I have given you a piece of three-dimensional graph paper. Okay, I'm going to have you on the next page, on the next slide, I'm going to go with you, draw with you an XYZ axis. I would not take up the whole page with the axes that you draw. What I would do is like on the left corner, like the upper left corner, we'll draw a set of axes and plot some points. And then you can use like the right side of the page for your homework. That way if your notes and homework are all together. Because half of your homework will be plotting points. Okay? So, here we go. When you are asked to plot points, I'm having some major issues with my smart notebook, so stand by. Got it. All right, so what I need you to do is draw a z-axis. And our numbers won't be very big, so it doesn't have to be super long. Here's our x-axis. And our y-axis.
Is the x-axis going to be right in the middle and the y?
What?
Is it right in the middle?
No, it's
I mean, you can make them however long you want to, but I'm just trying to be symmetrical here.
It's confusing that y is not.
Yeah, that's weird.
all I can see.
Well, what you can imagine is, like, we're used to the XY plane, and so we've laid it on the floor and then added a third dimension. Okay, so I know it's awkward right now, but if you think about the XY plane being the floor,
I feel like it's going horizontal.
You're looking at it at an angle, like on the above angle.
yeah, we're kind of like taking pictures from above. Okay, all right, so let's plot 3, 0, 0. So on the x-axis, we're going to move in the positive direction 3. Y is 0 and z is 0. So we'll just plot our coordinate there. This coordinate does not lie in an octant. How could we describe where this coordinate lies?
Coordinating edge.
Okay, which plane?
The XZ plane?
The xz plane?
I think no.
Yeah.
Also lies on the XY.
It also lies on the xy plane. So it lies in the xy plane and it lies in the xz plane. Okay, since it's on an axis, it lies in 2 different planes. Good. Let's plot 4, 0, 4. What I would do, since you don't have different colors to label these with, I would label 3, 0, 0 right next to that point you just plotted. That way you know what point it was. Okay? Now we're going to do 4, 0, 4. So I'm going to move out on my x-axis 4. We don't have to move any in the y direction, but we need to move up 4. Now, if I move up 4, it looks like it's on the y-axis, but it's not. So what we're going to do is we're going to leave a trail, like some breadcrumbs. Okay? We're going to leave a trail so we can see the path that this coordinate is taking to get to where it is. So now we can imagine this lying above the x-axis in the xz plane. Can you visualize that?
Yes. How are you going to graph the lines?
We're not. Okay, questions there? Okay, we're going to do 2 more points. You can do these on the same set of axes, but I have to draw a new set, so bear with me here. Here is Z. Okay, now we're going to plot 2, negative 3, 5. Now what we're going to do, we're going to move in the xy plane first, and then we're going to move our z coordinate. So if we move 2 in the positive x direction, 3 in the negative y direction, what I'd like you to do is create a parallelogram, and then from the corner of that parallelogram, move the z coordinate. So we're going to move up 5, leaving that breadcrumb trail every time you move. So you're going to make your trail in the xy plane. It's going to look like a parallelogram. And then from that corner, make a trail moving your Z direction. Who can tell me which octant this coordinate lies in?
Four.
I'm hearing 2, I'm hearing 3, I'm hearing 4. I'm hearing more 4s now. Okay, so remember, 1, 2, 3, and 4 are the octants where Z is positive. Okay, we start here. This is octant 1, 2, 3, 4. This is an octant 4. You okay with that? It is fun. All right, next, negative 2, 6, 2. So we'll move negative 2 in the X direction, 6 in the positive Y direction. Make your trail of a parallelogram, and then we can move up 2. My calibration is still not awesome, but you guys can bear with me here, right? Okay. Now, which octant is this red coordinate in? That was a pretty firm 2. Everyone okay with that 2? Cool.
I know that plot before, I don't know how you get these options.
Okay, does somebody at your table have a book? You guys can open to 11.1.
Like, I'm looking at it in 2 meters now, I don't know how you're going to do 3.
Okay.
Turn
Turn to 11.1.
Negative part of the axis.
Okay, stop. Right there. On page 774, at the bottom of the page on 774, there's a diagram that highlights each of the octants. Cole, is that helping?
Yeah, so...
So do you see how we move back, right, and then up?
You said this one was in the second quadrant?
Second octant, yes. Cole, does that help?
Purple one
Yeah.
was
The what?
the first one was in the.
Yeah. All right, the next thing and the last thing that we are going to do is talk about distance. Somebody please tell me how we find distance in a plane. Pythagorean theorem, okay, which is used to come up with the distance formula, right? What's the distance formula?
Square root
Just 1 minus 1, 2 minus 2 minus 1 minus 1 squared.
Okay, I hear a lot of mumbles that are coming out to be this. Okay? Any ideas on how this is going to be adjusted if we are in 3 space?
You're gonna add a y and a z. You're gonna add z.
You're adding a z.
Z squared minus...
Still square root because we're still based on Pythagorean theorem, but we added z minus z squared.
You came up with this one.
So,
I don't know.
I'll show you how they came up with it. It's just another Pythagorean theorem.
Senor Pythagoras. That is me. Pythagoras.
I'm not
Is it really? Yes. It is Pythagoras. Pythagoras.
If you want,
I'm Spartacus. He's probably Greek. Pythagoras.
one time,
You got some oranges, you got backwards.
Okay, so over here, okay, Alex has a question about plotting points, so hang on, guys. So you find your X and your Y, and you make a parallelogram, and then you can move up or down for your Z.
And that's where it
Uh-huh. Yeah. Okay, so now, please bear with me. I want to explain why this works. Because most of us intuitively say, that is Z minus Z squared. But why does that work? Okay, let's imagine two coordinates in space. Okay, so my hands are two coordinates in space. Okay, now I'm going to draw them up here on a 2D plane. So the visual isn't going to be so awesome, but I want you to just bear with me in a minute. Okay, so we have these two coordinates. Everything is different about them. They're X, they're Y, they're Z coordinates. It'll help our visualization. Okay, I am going to add a third coordinate here. Okay, so here are the two coordinates. I'm going to add a third coordinate right here. Okay, so just below this coordinate, I'm going to plot a point, and this is going to be in the same plane as this one. Okay, so here are our two original coordinates. We're trying to find the distance between them. Now, since I plotted this coordinate directly below, the only thing that differs are their Z coordinates. So if I want to find the distance between those two coordinates, how would I do that? Okay. What is that difference of these, right? Okay. Now, these 2 points, what did I say about these 2 points? They're in the same.
So they have the same, or do they have the same?
They have the song, I get it.
They have the same Z, so they're in a plane. Oh, how do we find distance between 2 points in a plane? Okay, so I have created a right triangle. Pythagorean theorem, hypotenuse squared equals leg squared plus leg squared. A square root and square cancel, and to solve for D, we square root this entire side. Distance formula in 3 space. Still based on the Pythagorean
So
theorem.
like if we're looking at our coordinate plane, the bottom part is going to be a line that kind of runs in the box created when you try to build that right portion.
Well, if that first point is in the XY plane. Okay, these could be anywhere though. Okay, so these both could be above that XY plane. All that I want you to picture is that these 2 points lie in the same plane. So we can put a piece of paper. Okay. All right, let's do an example. Okay. As a reminder, it does not matter the order in which you plug these points in. Since we're subtracting 2 numbers and squaring them, it doesn't matter. Okay? So why are people getting out their calculators? No. We have 4 minus 2 squared plus 1 minus 1 squared plus 9 minus 6 squared. Noah, what is 4 minus 2, the quantity squared? Alright. Justin R, what is 1 minus 1, the quantity squared? And SK, what is 9 minus 6, the quantity squared? Square root of? No, you don't. You can do it. Okay? That's it. That's all we're doing today.
Oh,
We're done? Serious? We're not gonna graph anymore documents on them?
Well, we're done with notes. What I'd like you to do is write down your homework, and then I have a quick activity. It is Monday. It's dreary outside. We need a little pep in our step, so we're gonna do a short activity, and then I'll give you plenty of time to work on your homework, okay? Don't make fun of how I talk. I hear some of you giggling about what I said. Pep in your step. Oh.